Hey, what you doing?
Me? Oh, I'm watching the greatest movie in the history of cinema.
Oh, It's a Wonderful Life. I really love that film.
No, not that movie about where all the bad people get to keep all the money they steal. No, I'm watching The Magnificent Seven.
Okay, that's a good one too. You know it's based on a Japanese film, The Seven Samurai.
Yeah, and that's why I love it so much, because it reminds me of data security and privacy.
Okay, how exactly do those relate?
Because SQL Server has 7 features to help you secure and protect your data.
It has a lot of features for data protection, but 7 sounds pretty good. 7 features to help protect data at rest, data in use, and data in motion.
Yeah, and we could talk all day about data security and privacy.
Yeah.
I know I could, right? But I could also talk about Yul Brynner, Steve McQueen, James Coburn.
Okay, enough of that cowboy thing. Maybe we should start our Thwack Camp session now.
That's a good idea. I'm Thomas LaRock.
And I'm Karen Lopez. Today we're going to talk to you about the 7 Samurai of SQL Server data protection.
That's right. SQL Server 2017 plus Windows, they have 7 features to help you protect your data at rest, data in use, and data in motion. So let's get started. So I was watching the movie the other day with my son, and I couldn't help but see the parallels between the plot in the movie and the current struggles we face with data security. So here's the example. Let's consider that we have the bad guys, and we'll call them adversaries. And these adversaries want our data. And it's up to us, the villagers, or data professionals, to go find and deploy proper data security measures to guard against data loss or theft, right? That's how this works. So the adversaries, we stop them, but they'll come back. The good guys have to fight back. And there's a happy ending for most.
Yeah, so there seems to be a never-ending supply of data breaches and leaks these days. It's so much easier these days to build applications and just put them out there. Too many times this means data security, data privacy, and the quality all come in second place to building shiny new apps that upload pictures of cats or help us identify the difference between a dog and, or is it a blueberry muffin?
Yeah, that's a good one. So this SQL Server has wonderful features to help protect us from 3 different attack vectors. So that's your data at rest, your data in use, and your data in motion. And what we're going to do today is we're going to break down into those vectors, and we'll speak to each feature that helps with each one of those vectors.
That sounds good. Let's start with data at rest, though.
Okay.
So data at rest refers to data stored on files on disk. And examples are database files, database backups, or even things like Excel spreadsheets. Protection for this data includes traditional methods like using permissions and firewalls and antivirus programs. But those methods aren't enough when it comes to physical database files, where the data is. If an adversary makes their way past, they may be able to copy the data files from one machine or the backups and restore them to their own servers.
So how do we protect our data at rest then? I mean, what options do we have available?
To protect this data, we can use the following samurai: transparent data encryption, or TDE, Bitlocker, and backup file encryption. So TDE allows for real-time encryption of both data and transaction files. That encryption happens on the database page level. The pages are encrypted before they are written to disk and decrypted when they are read back into memory. This means that a database backup file cannot be restored to another server unless you have the necessary certificate.
And that's important. So let's say, if your backup tapes are, say, borrowed by an adversary, or they just happen to be there when the backup tapes fall off a truck, right? So TDE will help to mitigate that risk.
Yes, of course there are some trade-offs for using TDE.
Okay.
For example, your temp DB is encrypted, but the temp DB is shared among all the databases for the instance. You'll want to test.
Yeah, you always want to test. And so you also want to test not just for performance, but practice restoring these backups to different servers. You also want to practice key rotation as well.
You don't want to lose your keys, trust me on this one. You need a place to store them, like Azure Key Vault.
All right, so can we take a look, see how this all works?
Okay, so we're here in SQL Server Management Studio looking at some T-SQL. Going to show you what the data looks like before we encrypt it. Going to show you what it looks like after we turn encryption on.
Okay.
So we're just going to take a look at some person information in the Galactic Works database.
Okay.
So we've got some codes: state province code, country code, is only something flag, flags are evil, some names, territory ID.
Tasty goods.
Tasty goods. Goods are good, or not.
Goods are tasty, maybe.
Something like that. So now we have to flip over and use the master database, because some of the next work we have to do is at the instance level.
Yeah.
So the first thing we're going to do is create a master key.
Yep. So we have to create a master key inside the master database. And that's like step one, because step two is you're going to create a certificate, and ultimately we're going to tie that certificate and key together, right, as we'll see. So
in our demos, we always use strong passwords called use strong password here.
that's a nice reminder that that's something you shouldn't be doing or using in production.
In production.
Please don't do this at home.
Yeah. So the next thing is to create a certificate that protects it.
So we now have a key tied from the master database. There's a key in the master database, and there's a certificate tied to the instance as well.
So now the next step is we're going to go and create that key back in the database we're trying to protect. We're going to say how we want it to be encrypted.
And you notice the line there, towards the bottom, encryption by server certificate, right? So this database encryption key is using that server certificate, which is also tied to the master key.
Yeah.
Right.
So we're doing that. Now we've got some warnings that are important.
Let's see if we can show the entire warning message here, because I think it's kind of important for people to understand. So what's happened is, as of this moment, the system wants you to know, hey, look, you've done everything correct up until this point. But here's where you can make your first serious mistake with encryption, that you need to be backing up your keys. I mentioned key rotation in the intro as well. So you're probably not going to want to use that same key forever. Sometimes you rotate what's a standard, 180 days maybe?
Something. I guess it depends on your data sensitivity and everything.
There's probably an industry standard for your particular business, but more than likely your auditors probably have an idea of when your keys should be rotated. So this is telling you right here, it's very clear. Now it's not, it says warning, and I think it should be in red. Of course, that would indicate an error. But they've done their best to help you understand the importance of backing up that encryption key. You should immediately back those up, and you should store them somewhere where they don't get lost. For example, maybe Azure Key Vault.
And maybe not on a shared server somewhere. Maybe not in your personal email account or anything like that. It's also, it's like, you know, you want to hide your house key in the house pot, the flower pot outside your doors? Lots of people do it.
That's where I first
people learn not to. That's where you
so, in the last sentence, if the certificate is ever unavailable, and if you must restore this database to a different server, you got to have a backup of both the certificate and the private key, or you won't be able to open the database. So I mean, if we're just talking, if you decide to do this in production and then you want to do a quick restore down to dev for somebody, right? You're not going to be able to do that unless you've already moved that certificate and private key.
Okay.
Now,
so,
is encryption on yet?
Nope, we're just about to do that.
Right.
You're very impatient.
No, I'm just pointing out, you've done everything correctly. Encryption still isn't even on yet.
Yeah. Okay. Now it's turned on, right?
Just so like now, that? That was fast.
Now we're going to show the data. It's all going to be encrypted, right?
Sure.
Okay. Oops. There it is. Oh, wait.
Yeah. So this is
what did I do wrong?
This is the transparent part of transparent data encryption. So if you are Adam in accounting and you're opening up Excel and you're interacting with the data, you have no idea or knowledge that the data, that TDE has been deployed. This was one of their goals, was that they wanted to give away, Microsoft wanted to protect SQL Server with a method of encryption for data at rest without impacting users or queries in any way. And that's the transparent part, is that the data, there's no ciphertext here. So if you were coming here and saying, you know what, I really need this particular column to be encrypted so nobody can see the actual data, that's not what TDE is going to do for you. Right? TDE is protecting data at rest, not data in use or data in motion.
And so can we, like with other technologies, can we say my data gets encrypted and yours doesn't?
How do you mean exactly?
Well, I'm assuming the way you described it is because it's just at rest and not when it moves, that it applies to everybody. Like all the data is encrypted all at the same time, and there's no...
I see. So it's the entire database.
Yeah.
That's right. It's not like we did this just for one table or one schema. When you do TDE, it's at the database level that's being protected. So anybody using that database, and of course TempDB is encrypted as well, because any TempDB query or any database could use TempDB. And so that would be, you have to protect that at rest as well. So any query that hits TempDB, therefore TempDB must be an encrypted file. have
So
TDE.
if I have another database on the same instance, now there's only one shared TempDB,
That's right.
and now its data gets encrypted when it hits TempDB as well.
Right, and so therefore there could be a performance impact for any user of that entire instance.
A trade-off.
There's a trade-off. So you have to do your testing and say, hey, how much impact is there if I enable TDE? Now it's designed to be minimal impact.
Right.
They say 3 to 5% extra CPU type. It's supposed to be a minimal amount of performance impact against your SQL Server instance.
Cool. Cool. So what we're going to do now is I'm going to do a backup of this, of my database, which has had encryption turned on.
Okay.
And then a bad guy comes along, right?
Can I be the bad guy? Can I be the adversary?
You be the adversary.
Let me be the adversary. So now that now we have this backup running, what it is it's going to include the certificate. It's going to include pointers to the certificate and to the private key. So okay, the backup's done. So I have this syntax, so we will just grab this real quick. And I will go to, I have a second instance, so I'm on the same server even. So we talked about moving it to a different server. I'm going to show, even on the same server, this backup can be fairly useless against a second instance because that instance doesn't have the private key and the certificate tied to it. So if I go here and I just say new query, and I paste, and I execute to run that, there you go.
Oh.
So if you've ever seen this error message, you have an idea of what's really happening. And that is this database, or that, and we'll see later another option, right? But there's encryption in this database file, and you aren't being allowed to restore it. And if you get to this message and you don't have a key in the certificate, you're in trouble. It's going to be a lot more difficult for you to find a way to get that data out.
So whether you're an adversary or a good guy trying to get business up and running, you're going to get this message, and to fix it, if you're the good guy, is to go find the key in their certificate and get it moved.
That is the best option. Otherwise, you're going to have to copy the data out by hand.
Or borrow someone's thumbprint. Is that what that means?
Yeah, I could file off, or yeah, I could, sure, I could borrow a thumbprint. Okay, so again, the idea here was to protect data at rest.
Yeah, we did.
And I really believe that this is a method that does that with a minimal amount of impact. Matter of fact, in Azure SQL Database, these days, everything TDE is enabled by default these days.
Okay, so they've decided this is a good way of doing it.
That's right. So if it's working in the cloud for them, it probably is something you should consider as well.
Yeah, so we've learned that the benefit of doing this is it's transparent. So there's no cost. I didn't have to change any of the application. I didn't have to get a new version of Excel. It's just still doing its stuff, right?
Yep.
So that's the benefit. It might have a small impact on performance, as encryption does, because there's a trade-off there. The risks for it is if someone encrypts all your data, your business data, and then the key and the certificates aren't managed, you could lose access to that data, right?
Correct. Well, you lose access to the ability to move that data to a different instance. Correct.
Yeah, but if your hard drive's failed and you need to restore,
that's right.
Right, now you're kind of out of luck.
Yep.
Yep.
Okay, so Samurai number 1 was TDE. We got a nice run through of what that is. So what's Samurai number 2?
Bitlocker.
Okay, so tell us about Bitlocker.
Bitlocker is a built-in tool to Windows that allows for you to encrypt your data volumes even when Windows isn't running. If an adversary were to gain access to your hard drives, they wouldn't be able to access the data by taking that hard drive and attaching it to another server.
Usually when I hear Bitlocker, it's usually applied, you think about it when a laptop is lost or stolen, right? So it's usually a thing for laptops, but you could also do it for database servers.
Absolutely. And if our foe tries to take the disk and use it elsewhere, it just won't work. Bitlocker is one of those things that makes sense to use on laptops and sometimes on database servers as well. Again, you'll want to test to see if there are performance issues after applying Bitlocker. Yes,
test, test, test. You're going to hear us say that word a lot today. Now, we're not going to demo Bitlocker here today because it's not that exciting. It's simply a command line that says encrypting your disk. So let's move on. Samurai number 3, who's that?
Backup encryption. This is a feature in SQL Server that allows you to encrypt the contents of backup files. The encryption does not need TDE enabled, but just like TDE, if you don't have the right certificate, you won't be able to restore from the backup file.
So I often tell people the very minimum they should be doing on their database backups is using backup encryption. There's no question in my mind. I recognize there's overhead With keys, certificates, the rotations, all that, absolutely. But when you think about it, database backups, you already know they're leaving your server. They're going across your network. They're going somewhere else. So why wouldn't you want to protect that? Since data is the most critical asset your company has, you should be protecting those backup files using encryption.
Absolutely agreed. You don't want your backups being restored somewhere else, even within your own company, that you don't know about.
Right.
This is an easy way to ensure that won't happen.
Okay, so let's take a look and see how simple this is.
Okay. So we're back in SQL Server Management Studio, and we've got a script to demo this. And the first thing, just like with TDE, we're going to need to create a master key.
Okay.
So, and again, with a strong password.
Yes.
Don't use this.
It should say super strong password.
Yeah, we should probably do that. Yeah. A samurai password would actually be a great way of doing it. And then the next thing we're going to do is create that certificate as well.
Yeah. Okay.
And there we
So
are.
now we got our key, we got our certificate. So
everything's encrypted,
just
right?
like TDE, right? I mean, no, you had to do those first two things.
Yeah.
You need a key, you need a certificate.
Yeah, but we haven't encrypted the database, right?
No.
Because not here, we don't have to.
No, we're not going to encrypt the database. We're just going to encrypt the backup file.
Mm-hmm. So now we get to the command where we do this backup and tell it to use encryption, right? So we tell it where we're going to store it. It is good to try to give it a name, if you can, that shows that it's encrypted, to remind people that they need all those special keys.
Or to remind the adversaries to stay away. Yeah. You'll never get through this encryption.
That's right. And so we're compressing it, we're encrypting it, we're saying what algorithm that we're going to use that, which certificate we want to use.
And that's the key there, no pun intended.
Yeah, exactly.
Server certificate, that flag right there, so tied to the cert that we created, tied to that master key.
Yeah. So we'll go ahead and run that. So while it's doing the backup, it's encrypting the data as it puts it in that back file.
Yeah, it's encrypting the database file. That's right.
Yeah, but it's still not doing anything to the database.
No, no. So it's not TDE at all, right? Yeah. So it's just for that backup file. It's not for the database. So your tempDB isn't encrypted. It's just encrypting that database file. So can I pretend to be the adversary again?
Sure.
All right. So what we're seeing is, again, we have this database. Now I can come in here and I can grab the same syntax and I'll go over, create a new query in the other instance. So same instance, right? I'm not even moving off the server. I'm just going from one instance to another. I did a backup using backup encryption on one server instance, and now I'm going to this other one. And when I execute, I get a very familiar error message right now. So as I hinted at earlier, when you see this message, you can't find the certificate with this thumbprint, and you're trying to do a restore, then it's one of two things. Either the backup file was encrypted, or your database had TDE on it. It's one of those two things. So what are my options at this point if I really need to restore?
Get the keys.
Get the keys. Get the key and the certificate and get them moved over. But what if I don't have those? Yeah, same thing as TDE. You're going to have to move the data by yourself. So there's cost, benefit, and risk to each method. So some of the cost, benefit, and risk for TDE would be things like what? tempDB being encrypted.
Yeah.
What else?
The fact that it does the whole database, not just the sensitive data.
Right.
But here, the benefit for backup encryption is you haven't messed with the database, you haven't impacted performance. Even then, someone could turn that on and backup encryption would still work, right? Then you'd end up being encrypting an encrypted backup of a database.
You could do both. It's possible to do both. The question's always, what's the benefit? What's the benefit?
Yeah, and all these should come down to a business decision. That's why I keep going on cost, benefit, and risk. That's how businesses make decisions. So the benefit of doing backup encryption here is that we know these files, backup files, by nature tend to move around a lot, tend to go to third parties, tend to go to other cities or countries or other clouds. Like, it's all important that if you're intentionally moving data around, it should be encrypted. So that's the benefit of it. The risk is losing the keys and everything. So, but like, a backup isn't as great if it can't be restored. So you have to have a way of moving the keys around and managing the keys, as well as not moving them around together, like taping your car key on the outside of your car so it's always there when you need it.
Or a Post-it note on the server tape that's going off to Stone Hill, and it says, here's, by the way, the encryption key. Right. Yeah, you don't want to be doing that.
Or
but
just
It's part of the cost.
Yeah,
If you want to use this method, is keeping track of those keys and certificates.
that's right. And maybe using different keys and certificates across different data sets or databases or days.
It does.
right?
It does add complexity. There's no question. I believe it's
Yeah.
worth it.
Yeah, because the risk here is a lot of the data breaches we hear about are ones where people have moved unencrypted data sources up into a bucket somewhere in the cloud to move it somewhere because it's faster and the network might be faster to the cloud and back out, and all of a sudden it's unprotected data sitting in the cloud, and that becomes a data breach.
Okay, that was great. But that's the end of data at rest. We want to switch now and talk about data in use.
Data in use refers to data being put to work, my favorite. Data in use is more vulnerable than data at rest because those that need to use it often end up accidentally sharing that data with other people who shouldn't see it ever.
Right.
Social engineering is one method that an adversary will use to access data in use. But an adversary could also access a spreadsheet on a USB drive that you left behind on a bus.
Yeah, I've been there, done that. I knew a guy, he left the USB on the bus once. His company was on the news 12 hours later. So how can we protect data in use?
Well, to protect it, we will be using the following samurai: dynamic data masking, or DDM, and row-level security, or RLS. I always think of dynamic data masking as a superhero of some type.
Right, because of the mask, right?
Yeah.
So like data backup man?
Or data restore man. Anyway, dynamic data masking allows you to limit exposure of sensitive data by applying a standardized mask to data at the end of a query operation. The performance impact of applying this mask is minimal because it happens at the end, not inside the database engine. DDM is a great way to help avoid issues that arise when users take their work at home at night but forget the printed documents in the seat back in front of them.
Oh, now you tell me.
Yeah.
All right.
Do you want to see how it works?
I do. Let's take a look.
Okay. So we're back in T-SQL land, and we're going to look at dynamic data masking, that superhero I like.
Okay.
So we're going to use the Galactic Works database.
Here, I'll clear that.
And then we're going to create a table, but this table has some interesting features. It's a membership table, so it's just got a regular membership ID with identity. It's got an account number that uses this calculated function stuff to generate a account number based on a member number. Then it has a first name for a member, I'm assuming, and we get this syntax here that says masked with, and then we have a function. And I can tell from looking at this function, this is one of dynamic data masking's featured ways of doing it, a custom mask. So that's one of your options when you mask, is you can design your own custom mask. And when I look at this mask, it looks like it's going to say, give me the first character of the original data, the original first name, then pad it out with some X's, and then the last two gives me what?
So if I read this correct, by partial in that mask would mean, so the first letter, then followed by 5 X's, then followed by the last 2 letters. But of course that depends on if the original data has that width to begin with.
Yeah.
Otherwise you don't get it.
So like if it was Tom,
right.
we're not going to get, it's not going to make your data longer.
No, it would probably be a T and then 5
some
X's.
Yeah, we'll see. And then the last name, just regular last name, unmasked. There's no mask to it. And then we have a concatenated column, which is a full name that has a first name plus the last name.
So the key being there is that the first name is something masked.
And the last name isn't.
And the last one isn't, and you're combining, so something masked, something not, into yet another column. So we'll see what happens.
See what happens, right? Then we have a phone number that's designed properly, yay, as a character, not a number. And it's masked with another option. So we had a custom option up here. Now we're going to have, it just says the word default. And the way SQL Server works here is it has a default mask that it will use based on the data type of the original data. So in this case, it's character data. So we're telling SQL Server here, use whatever default you do for character data.
Okay.
But then we have email address that's masked with a function, a specific one called email. And email, what it's going to do is apply a, if we use this function, a standard mask for emails every time we call it email. Right. And we'll see what that is, okay? And then we have some sample data to stick in here. So some first names, some last names, and then we're also concatenating those together as full name and their phone numbers and their email address, right?
Okay.
So we're going to go ahead and create the table, put the data in it, and show you the data.
Yep. So what's getting returned right now is just simply SQL Server or Management Studio showing us what got inserted. That's all.
Yeah, that's all it is.
Okay. So that's the data that's in the table. All right. I'm sorry, I did, because we did a select at the end of it.
Yep.
We did the insert, and then I did a select just to make sure that the data's in there.
Mm-hmm. And then what's going to happen next is something you'd want to do with masking certain data, is because unlike just encrypting an entire database, we have the option of letting some users see the data unmasked and some always seeing it masked,
That's
right? One of the things I wanted to say is, as we pointed out in the intro, when we apply these masks, it's not doing it down in the database, right?
Mm-hmm.
When we see data, we saw it when it first came up, it was not masked.
No, there was no mask.
It doesn't change any data. It's basically going and doing the query, like the select all, doing the query, pulling that data back, and applying the mask right there, right before it shows it to the end user, right? Yeah. We're going to create a specialized user. So we're going to first give the user permission to do a selection.
Okay.
Mm-hmm. Whoops. Yeah. And then we're going to execute that.
And there's the mask.
And there's the mask.
So, you know, that's fancy and all, but you're just sitting inside Management Studio. That's not a real world example. Mm-hmm. I think I have a better example to show.
Okay, because usually if the end user is seeing masked data, they're not using Management Studio, right?
Yeah, they're probably not using it. Like, you know what? What's Adam in accounting seeing?
Yeah.
Right? So let's pretend DDM user is Adam in accounting. So he probably has this spreadsheet. Let's refresh this. And there it is. You can see that I bring up, because this is the world's, you know, most used business application, Excel.
Yeah.
And you can see now this person that has to work with this data, what is coming into their spreadsheet is just the mask data. And again, the mask is applied at the end, so the performance impact is minimal.
Right, it's doing all the matching and sorting and filtering and joining on tables using regular data.
So what happens when this ends up on the USB that's left behind on the bus? Mm-hmm. The data isn't exposed because there's a mask involved, right? Mm-hmm. So this is what he sees right now because he's DDM users only allowed to see masked data. Right. So what happens if we unmask?
Mm-hmm. So one of the things though I wanted to point out is, look, the email address this was the standard one.
Right.
We didn't say the format. It gets the first letter of the email address, X's for everything else, and then every single email address gets changed to .com, whether it's a .org or a .net or any
Always
of that
.com.
stuff. Yeah.
So let's go back. Let's grant the unmask.
Right.
So revert. You have to
do it all at once.
Okay.
So we're reverting to the user.
Mm-hmm. So now if we go back to that spreadsheet, right? Sure. If we just go back to that spreadsheet. And if I hit refresh, what's DDM user get to see now?
Now he gets the
Now he gets everything because he's been granted the unmask permission. So that's how easy it is as an administrator for you to apply a mask or take it away. Okay. And that way the end user is getting the information that they really want. I really like masking because I think, now remember, it's not encryption, it's just a mask.
Yeah, it's a privacy feature, not a security one.
Sometimes people talk about it being an encryption feature, but it's really not. It's a privacy feature, and I think it's a really good one for you to be using, especially if you can identify PII data in your database.
Because data's moving out on a spreadsheet.
So that looks great, and that dynamic data masking, that's a feature I wish existed years ago inside of SQL Server. So, but any risks associated with DDM?
Well, DDM is an encryption that gets confusing at times. It's meant to complement other security features. It's possible for an adversary to write some edge cases with pieces of code that would allow them to guess the contents under the mask. That being said, it's still a really useful feature for everyone.
Agreed. So let's move on to the next Samurai and let's talk about row-level security.
Yeah, RLS allows you to create security policies that will filter data as it's returned from the underlying tables. The user has no idea that any filtering took place. When combined with dynamic data masking, RLS gives you the opportunity to reduce your risk that data in use will be seen by people it shouldn't be.
So this RLS, this sounds like some sort of fancy filtering?
Yeah, it's based on predicates and filters that you define. Let's take a look at how it works.
Okay.
So we're back in Management Studio, and we're going to take a look at a script that's going to show us how row-level security rolls. Can I say that?
Yeah.
Yeah. So we're going to use our Galactic Works database, and we're
Okay.
going to create a table that has some order IDs, a sales rep name, a product, and how much they sold. Let's just say that, right?
All right.
So we've done that.
Here, I'll clear that for you.
And now we're going to insert some sales data and take a look at it.
All right.
And there we have.
And we're seeing this, of course, we're the sysadmin, so we're returning all the rows, and
Yeah.
just to show you what was inserted. All right.
Yep. So now what we're going to do is create some users, some of those sales gals and guys, and a manager.
Okay. So we've got the users created, and we've granted select on that object to those users.
That's right.
Okay.
That's right. So now we get to the fun part.
All right.
We're going to create a schema.
Now, is this a recommended thing, creating a new schema?
I think it is for dealing with security things.
Yes,
Right?
I believe so as well. So when you're doing row-level security, a lot of the documentation talks about it as well, is creating a new schema. I'm not sure I would name the schema security, but having a dedicated security to hold these schema to hold these objects is actually a really good idea.
Yeah. So you wouldn't have to do it this way, but the way we're doing it is we're creating a function that treats the logged in user's name and it's going to compare it to that name column that we created for
That's
the
right.
sales rep.
That's right.
And the other thing we're going to do with this security function is we're setting our filter is where the person running the query is the same name as the salesperson name in that row or the manager.
Right. So essentially, we have to create two objects here. This is the first one, and the name is security predicate filter, right?
Mm-hmm.
And that is essentially what you see there is the filter is on username. We pass in the sales rep name is going to be passed into this predicate, and it has to match either the username or the username could be manager.
That's right. So in the next step, we're creating a security policy. We're going to call it sales filter. We're going to say, here's the predicate you use
Right.
and on what table, and we're turning it on. The state meaning status.
Yes. So now the filter's in place. Okay.
So now we're going to impersonate some of the people by using execute as,
Okay.
right? So now I'm going to be sales gal 1,
All right.
and I'm going to run a query where I want to know all the sales data. Remember, I'm doing a select star, and I'm selecting it and
Right.
saying where from. There's no filter, there's no where clause in my query.
So changing the context of sales 1, selecting everything from the sales table. Okay.
Yep, yep. So I should see all the rows in the sales
You
table.
should. Why
Yeah.
not?
Except that I don't.
No.
Why is that?
So the filter, the security policy has a predicate, and the predicate, it says only return the rows that match the username where the sales rep is equal to sales 1, because that's the person that we are right now. So I can only see my rows.
Because it's been filtered. And then we have some aggregate data of the total sales and the sales average.
So what you're saying here, what you're showing is that sales 1 thinks the sum in the sales table right now is 10. But what they may not know is that that's just their sum.
Yeah.
It's not a summary for the
Like
entire
I'm
table.
sales 1 right now and I'm rocking this sales, right? I'm responsible for all the sales.
I have 100% of the sales.
Yeah, this is gonna be great.
So what happens if we change over to sales 2?
So now, now I'm gonna be sales guy 2.
Wow.
Wait,
Now they only see their rows, but they think the sum is 14, and they have 100% of the sales. So sales is rocking it. They're at 200%. So how about the manager?
yeah, so now the manager, she's gonna run this and she's running the exact same query, but because when we defined that filter, we said if the logged in ID equals the sales name or is manager, they get to see it all.
So the manager gets to see what the real total is.
And knows that the average sales is 4.
Right.
Yep.
Okay.
Okay. So that's what's happening.
So now, and it's easy to turn this on and off. You
Yeah.
can just alter it and say off, and then what will the sales 1 see? Let's do that.
Yep, so that's done. And now we'll see what the sales gal,
And now they get to see everything.
everything, because the policy's turned off.
That's right.
Right?
So the objects are still there. You just decide to turn it off for whatever reason you want to. But it's a really easy thing to turn on or off. Once you get it set up, that way people can only, so think of things like doctors and patients.
Yeah.
Like how much access or somebody, a hospital admin staff, should they see all the patients? information, or should they only see some of the patient's information? This is where something like a row-level security really shines.
Yeah, and the way we used to do this type of filtering in the old days, we had a few options. We could create a view, and we could create a view for each doctor, each nurse, a different one for emergency room staff. We could create a view for the managers and for the DBAs, and then people would only be granted access to that view, and the view itself would do the filtering. And sometimes we'd even have to materialize those views, meaning store them separately so they'd be fast.
Right, but these days it gets a little bit easier with row-level security, I think. I think row-level security is a better implementation than just trying to rely on those views.
Yeah, because I wouldn't want to create a new view every time a doctor gets a new patient or a banker gets a new customer. I want to just add them to a policy and say, boom, this is where it goes.
And the other method would be assigning people to roles.
Yep.
That was another way of doing it, views and roles, and I think there's a lot more overhead with that than relying on the data itself to kind of have a way of naturally filtering out what you should be able to see depending on who you are.
And again here, your application has no idea. It doesn't have to do anything. You don't have to change the application to change the filters or the functions.
Correct. Okay, that was great. Those are the Samurai for data in use, but now we're going to talk about data in motion. Tell us about the difference.
Okay, so data in use was more about data after it arrived, but data in motion is about data in transit, and it requires special protection. An adversary could use these methods, such as man-in-the-middle attacks, to access your data. And the best way to protect data in motion is to use encryption methods for your sensitive data.
So encrypt all the communication channels, right?
Yes. To encrypt data in motion, we will use the following Samurai: secure sockets layer and always encrypted. Okay. SSL allows for you to encrypt data that is transmitted between the client and the database server and back. SSL will force the client and the server to authenticate the identity of each other using a handshake. After the handshake, the connection becomes encrypted and data will be transmitted in a secure manner.
So I'm often shocked to find that there are websites out there not using HTTPS. That's just HTTP with either SSL or TLS, both forms of encryption.
Yes, it should be enabled by default, and most browsers will notify you if you're accessing a site that's not secure.
Right, and what I like is how host providers, such as mine, well, they provide SSL certificates for FREE, right? So, and I've often said, if people really want greater security adoption, well, they need to provide those tools and methods at little to no cost.
Yeah, and we are sensing these days that there's a great focus on security and a push to help people be more secure. SQL Server also allows you to communicate with SSL and is default for everything in and out of Microsoft Azure.
So let's talk about Always Encrypted.
Always Encrypted takes place at the column level in a table, encrypting the data so that only ciphertext is ever stored on the disk or brought into memory. That means AE will protect both data in motion and at rest, making AE my favorite Samurai.
Me too.
Data encryption and decryption happens only at the client. The only data transmitted between the client and the database server and back is ciphertext.
So you're saying that only ciphertext will be stored in this database?
Yep, that's right.
So even the DBA will not be able to see that data unless they have the key?
Yep.
So is there a performance issue with this ciphertext? I mean, is it going to be sargable?
Let's take a look.
Okay.
So we're back in SQL Server Management Studio. We're going to use our GalacticWorks database. Okay. And what we're doing is creating a new table called AE Demo. And we're just going to pull data, the first names, but they're going to be encrypted different ways so that we can see the difference. So we're pulling it from the person table and inserting it into the demo table.
Okay. So let's see what that looks like.
Yeah, so let's see what it looks like.
Ah, a lot of errands.
A's, it looks like it's sorted.
So what we want to show is different types of encryption and what's going to happen and what the ciphertext will look like when we're done. Right,
so all we've done is create it. We haven't encrypted it yet.
Okay, so how do we get the data encrypted?
Okay, so we're going to do this in the GUI just to show how fun it is.
Yeah.
And we're going to find our demo table.
Okay.
And we're going to go to Encrypt Columns.
All right.
Brings us up a nice diagram of how the encryption works. Okay. And we're going to choose the columns we want, which we know because we made this special table, that we're going to leave the regular first name column unencrypted, but we're going to first name encrypt it using a deterministic method and the first name as a randomized method, and there's a reason. We could also set different encryption keys here for each of them, but we're not going to do that for now. So we're just going to hit next, and we're going to use all the defaults here.
Okay.
And we could generate this as a PowerShell script, but because we can't just do it in TSQL because part of the stuff that makes Always Encrypted work has to happen at the server, not the SQL Server level, but the Windows Server level.
That's right. So there is no T-SQL script for Always Encrypted. It's always going to be a PowerShell script.
Or some other automation, right? So now it's doing it.
So now it does some checks to make sure that it can actually encrypt that column.
Because if there are some blockers.
There are some blockers, like if it has an index, it might not be a column that you can. So one of the differences between randomized and deterministic is that if it's deterministic, you can actually put an index on that column. If you choose randomized, then you aren't going to be allowed to index that column. So if there's an existing index, that blocker would come back at this point and say to you, sorry, I can't actually encrypt that column. In the GUI itself, sometimes it will flag that, but not always. Sometimes you get to this point and then the blocker shows up. But in an ideal situation, you would end up with the blockers being shown in the GUI, you would know ahead of time.
And there's, oh good, and there's some other options that are blockers as well, right?
Absolutely.
So I'm going to go ahead and close here. And am I rerunning this?
Yeah, just run that again. What happens now?
Look at that.
So the first column, we see Aaron's name. Then the next one that says deterministic, you can see that is the same piece of ciphertext.
Over and over and over again
Is
for
that
Aaron.
good?
Maybe.
It's good if you want to index using Always Encrypted. This is the good one.
Or do joins.
Or do joins, right? And you want to be able to filter and have, but randomized, you can see it gave something different each and every time.
For every instance that had a different ciphertext, even for the same value.
Even for the same value going in.
Right. So this one's actually more secure. But then your cost, benefit, and risk is there are certain things that you can't do with that type of encryption.
Now, again, we are the sysadmin right now. I'm only seeing ciphertext. Why is that?
Because you're not allowed to.
I'm not allowed to yet. There are two things that have to happen, right? We talked about you have to have the client key. Now I'm on this instance, so we have the client key. Right, you need .NET 4.6 or 4.7.
Some framework item,
you need some framework. So I'm only seeing the ciphertext for now because there's one more thing that has to be done. And that is we have to add in a connection string parameter when we connect to the instance. So what I'm going to do is I'm just going to say, let's just connect. It's the same instance. And I'll go over here, connection parameters, column encryption setting enabled. That has to be in there, right? So I will come over here and I will open up a new query. And we'll put that in. I'll make sure I'm in the right database, and we'll execute. So now what you see is the data unencrypted. So you have to have the connection string, and you have to have the client certificate, right? So what you would do is you would export this certificate key once you've generated AE on the server, right? You would then export that key to all the clients that need it, then probably want to save that key somewhere, but probably remove it from your database server, and then even the DBA wouldn't be able to see it, even if they add that connection string, because you need both things. You need the certificate, or you need the key, and you need the connection string enabled. But that's how easy it is to turn on and off for people to be able to see the data. And you notice the only ciphertext is ever communicated, and it's all done through parameters as well. So you always want to be thinking about using stored procedures in order to interact with the data. Hey, thanks for walking us through the Seven Samurai, Karen.
You're welcome. And you were right. This would make a great movie. It's a wonderful database.
For Thwack Camp, I'm Thomas LaRock.
And I'm Karen Lopez. Thanks for joining. Remember, every time someone secures a database,
a DBA gets their bacon.